Welcome to Tech Science Insights. If future technology excites you, consider subscribing for more mind-expanding discoveries. What if I told you that we might travel to distant stars? Not in centuries, but perhaps within this century? Sounds like science fiction, right? But recent breakthroughs suggest that warp drives, once confined to Star Trek, may actually become part of real science. In today's deep dive, we're exploring the possibility of interstellar travel using warp technology. What exactly is a warp drive? Could it really exist? And most importantly, how close are we to building one? Before we get to warp drives, let's understand why traditional space travel just doesn't cut it for stars beyond our solar system. The nearest star system, Alpha Centauri, is over 4.3 light-years away. With today's fastest spacecraft, like the Parker Solar Probe, it would take over 6,000 years to get there. Even with nuclear propulsion, we'd be talking centuries. In simple terms, using conventional propulsion, we're trapped in our cosmic neighborhood. That's where warp drives come in, as a potential shortcut through space-time itself. Let's break it down. The concept of a warp drive was first introduced by physicist Miguel Alcubierre in 1994. His theory proposed something revolutionary. Instead of moving a ship through space, a warp drive would compress space in front of the ship and expand it behind, allowing the ship to ride a kind of space-time wave, like a surfer riding a wave in the ocean. The ship would technically remain stationary within a warp bubble. No object is breaking the speed of light. Instead, space itself is moving. This means it could potentially allow faster-than-light travel without violating Einstein's theories. It was. Until now. In 2021, a team led by physicist Harold Sonny White at the Limitless Space Institute reported the first-ever nanoscale warp bubble. Though incredibly small, this was a real experiment that followed Alcubierre's theoretical model and produced an actual warp bubble-like structure. Let's be clear. This doesn't mean we can build a working warp drive yet. But it proves the math can exist in physical form, even in limited conditions. This was a huge leap from theory to lab evidence. Warp drives sound amazing. But here's the catch: energy. The original Alcubierre drive required more energy than the entire universe contains. Later calculations lowered that to a planet's worth. Today, new designs, like those from Dr. Eric Lentz, aim to bring energy needs down to something achievable, perhaps even using plasma or dark matter. Still, we're talking about technology we haven't mastered yet. So yes, it's possible, but currently incredibly expensive and impractical. There's exciting movement happening behind the scenes. Modified warp bubbles. New models remove the need for negative energy, a substance we've never observed, and instead use ordinary mass in strange configurations. Quantum field theory. Integration. Some researchers suggest combining warp ideas with quantum fields, which could theoretically allow safe and stable, faster-than-light motion. NASA's Breakthrough Propulsion Physics Project and DARPA have shown renewed interest in exotic propulsion methods, hinting that government labs are watching warp tech seriously. Absolutely. AI could play a vital role in simulating space-time distortions, discovering materials that support warp fields, optimizing complex equations that human minds might take centuries to solve. In fact, AI is already being used to accelerate physics research in quantum gravity, dark matter, and fusion propulsion, all of which connect to the warp drive equation. Even if warp drives become possible, should we use them? What if a warp bubble malfunctions? Could we unintentionally harm the space-time fabric? Who gets to go first? Space travel of this scale raises major questions about safety, governance, and interstellar ethics. And if we can reach stars in years instead of millennia, are we ready to meet what's out there? So, are warp drives close? Not next year, not even in the next decade, but the fact that we've moved from fiction to lab evidence is unprecedented. If energy hurdles can be overcome and materials evolve, we might see early prototypes in the next 50 to 100 years. That's closer than anyone imagined just 30 years ago. So while it's still a prediction, it's no longer fantasy.